Welcome to this talk, Duke on crack. Are you going to crack some jokes or?
Yes, there will be a lot of joke cracking and a lot of crack jokes, and in all ways and shapes and form. Yeah, we'll see. Yeah. We'll see about that.
Yeah. So my name is Ivar Grimstad. I'm the Jakarta developer advocate at Eclipse Foundation.
And my name is Rustam. I'm a senior software engineer at a bank in Norway.
Yeah, and if you want to follow me on social media, this is where you go.
And this is where you find me as well. So I created the easiest one is probably to go to that URL, rustam.no, and you'll see all the links there as well. Both of us are Java champions, Oracle Ace pros. You have some more stuff that maybe you want to mention?
Yeah, so I run the Java user group in Malmö, and I'm in the JCB executive committee, and also an Apache NetBeans committer, actually.
And I'm a Docker captain as well as a Google developer expert for cloud. So, we can talk about all things Java and cloud and containers and all that stuff. And if you have some questions that are related to this or maybe a little bit outside of this, feel free to ask, and we'll be happy to answer that.
Yeah.
All right.
And before we go on crack, we will just talk about Jakarta E in general, just to those that aren't using Jakarta E, so they will know what it is, a little bit about it, and then we'll go from there.
Sounds good.
Yeah. So, but before that, you probably can't have missed that Java is how old, Rustam?
Look at your bands, the lanyards. It actually might give you a hint. I think it's something with the 3 in it.
Yeah, so Java is 30 years this year. And I usually say that if it hadn't been for J2E, Java wouldn't have been 30 years. Because Java was created for tablets and displays and UIs. But it soon showed to be very useful for server-side. And then J2E came along in 1999 and conquered the world. I mean, most financial stuff runs on, all the money passes through some J2E stuff nowadays. I don't know if this is on our side or...
I think it's not. I think it's on the...
Yeah.
We'll see. Yeah.
Yeah, there we go. So, and, but you may say J2E was a bit over-engineered, maybe. So Spring came along in 2004. And they gained a lot of market share. And did some interesting stuff. We moved from one XML to another XML. And, but they introduced the dependency injection and inversion control, and those kind of things were useful. So when Java E came, J2E was rebranded to Java E a couple of years later, most of those things were picked up there. And these platforms evolved fairly much side by side. Spring also developed the JSR 330, which is add inject. So you can use add inject and add autowired interchangeably in Spring, for example. Spring Boot changed the game again in 2014. And that is the major platform people are using today. Jakarta E, the third rebranding of Java E, came in 2017 when it moved to Eclipse Foundation. And in 2020, we did the namespace change. And I'm sure you've, in some way or the other, experienced something around this. We're not doing it again. But we're now in 2025. And in 2024, we released the core profile of Jakarta E11. And we will fairly soon now release the web profile and the platform.
And it's kind of funny because when I do talks related to this, I ask people like, how many of you have heard of J2E and then Java E and then Jakarta E? And it would be like not really necessarily overlapping sets of hands. And it's kind of funny. And then you're just like, you know what? You could actually raise your hands at all those 3 and you would be good. But yeah.
Yeah. So Jakarta is all about specifications, and that will actually help us a little bit in the demos later. When we talk about specifications, Jakarta E, we have a specification document, a human-readable document that describes the technology. We have a API artifact that is a Maven Central that we, as developers, are using in our IDEs. And we have a TCK or test compatibility kit that is used to verify that an implementation fulfills all the requirements in the specification. And when it does that, it's a compatible implementation. And when we have an open source compatible implementation, the specification is ratified as a final one. And Jakarta 10, unfortunately, is the latest version out there because 11 was supposed to be here now, but it will be very soon. 10 had a lot of changes. Since in 9, we did the namespace change, and we didn't want to introduce a lot of API changes at the same time. So they were kind of bulked up and came out in 10. If we compare 10 to 11, you can see it's about the same amount of blue, which are the new specifications that are coming in 11. And we also have a new specification for data, which is a persistence. It's not a like data science thing that somebody asked me about, but it's persistence. It's like Spring Data. So we're getting to the crack, but Jakarta 11, I'll just go quickly through what that is. This is the platform. That is also a specification on its own. So all of these are specifications, but the platform is also a specification that contains all the specifications in Jakarta. We also have some standalones, but they are not part of the platform. They could be candidates for future releases, or it could be specification that has been removed in this or previous releases. A subset of the platform is the web profile. And web profiles is a set of specification more targeting the traditional web applications. You have everything from persistence to security to UI and RESTful web services. And a subset of the web profile, again, is the core profile. And core profile was new in Jakarta 10. And core profile is a set of specification that it's targeting microservices or headless services, if you want to call it that. And one of the key specifications here is CDI Lite. And CDI Lite is again a subset of CDI, but it is without the dynamic features that is resolved at runtime in CDI. So it can be resolved at the compile time, so you can compile to native images with the core profile. And Jakarta 11 is based on Java 17 at the API level. So we compile everything with Java 17 so that developers can use Java 17 if they're still on that platform. But we do make sure that the TCK runs on 17 and 21. So app developers can use newer versions of Java if they want to, and we want to. I mean, I'm using Java 23 nowadays on Jakarta 11, and soon we will use 24.
Yep.
Just a couple of weeks away, 1 week away, actually. The release cadence is that we want to release a version of Jakarta EE about 6 to 9 months after a LTS of Java. So next LTS of Java is Java 25 coming out in September. So next year, around summer, we want to release Jakarta EE 12. And the planning is going for 12. So it's moving at a fairly steady cadence now. 11 is feature complete. It was in May. We're just waiting for a refactoring of the TCK to be done. And I heard this morning that it is very close to be able to release the web profile. That could happen in a week or so. But everything is available in Maven Central. If you use Hibernate or something, or the implementations, they are there supporting Jakarta 11. And the theme for 11 is developer productivity and performance. And here you can see the stipulated release dates for the different. And it's a new thing that we're actually releasing the profiles and the platform separately. So that's something we're trying now, and it works fairly nice.
Right. Now we're back to cracking jokes and crack. And next time we should actually do a competition, so people should count number of times we say crack during the presentation. The person getting closest to that will get a prize of something.
Yeah, and
a cracker.
Yeah, and you've created some demos for this that we will show later. And,
yes.
And I guess you're using Java.
Java?
Yeah. Or did you ever consider using a language like Ecstasy or something for this crack demo?
Maybe. That might actually work. But I guess we should stick to Java.
Let's do Java.
Yeah, let's do Java. Okay, fine. No refactoring, live refactoring to Ecstasy. Mushroom. No, that's getting recorded. We shouldn't say that.
No.
Anyway, So let's talk about what actually crack stands for. So crack is, you can make a lot of jokes and stuff, but it stands for Coordinated Restore at Checkpoint. So there is actually, it is an abbreviation. And what does it mean? Well, that usually means that your application is running and it will, at some point, it will have a, something happen to it. Will something happen to it, but it's not going to necessarily know that much that something happened. So what will happen is that it will be aware of a checkpoint being taken. I'll explain what it is in a second on the next slide. And it will be aware of checkpoint being created because it will need to do some stuff internally to prepare itself for that. And it will also be aware of a restore happening. But your application is running as usual, but two things might happen to it, and in the meantime, it might freeze or something. And why do you want to do that? Well, I usually, the way I kind of explain it to people who haven't heard of it or used it or doesn't know the technology is I usually mention, like, back in the days when we had like Windows XP and stuff like that, we'd have a separate hibernate button on, like, shutdown, hibernate, and sleep or something. And then that is the hibernate thing. So it just dumps everything to memory, shuts down, and then when it starts, instead of loading everything up, it will just read it from the memory and do that. Our new machines and new operating systems still have it, but now it's much more hidden, just called deep sleep and stuff like that. That's why I kind of talk about the old stuff.
Yeah, that's how you can just close the lid on your laptop, and a week later you can open it and it's at the same
Pretty
state.
much, yeah. And this is the stuff you're doing now to your containers. And why do you want to do that? Because you don't really close lids on your containers that much. But what you can do is actually to make them run faster. So we stole this slide shamelessly from the guy in the room, Garrett. So this is actually, if you start, because we're talking about microservices, we're talking about micro nano services, whatever floats your boat. But the point is, and also we talk about serverless and things like that. So the point is, at some point you will be shutting down some containers and some applications, and you will be starting them up, and you will be scaling horizontally. You'll be starting up new instances, or scaling down to 0 if you want to do serverless, or to minimum, and then scaling up and all that. And every time you do that, it means that you need to boot up your containers. So normally it will look like this, where you will just have this boot up sequence, and then it's ready to, when it kind of flats out, then it's ready to serve stuff, right? And that kind of sucks, right? So what we can do is we can actually start it up, do what we want to it, like warm up JVM and all those fun things. Then we call the checkpoint, we store the state of it, dump it to the disk, create a new container with that dumped file or files. I'll talk about that later, a bit difference. There will be a little bit difference between ways you do that, but for now, you dump it store it onto a disk, create a new image of your container with that, as with extra parameters and stuff, and then you can just start them as, it's almost like save checkpoints in the games we used to have, right? You would just go to something you store, and then the next time you die, you will start from there. Pretty much the same thing. Right. Except you don't die here. That's good. How does it work? Well, you just add a dependency down there. It's almost true for almost all runtimes. I'll explain why in a second, but normally that's what you do. Some of the runtimes that we've been using, they have actually their own support for crack, so they will have actually their own little thing. I'll show that in a demo in a bit. But for now, you add a dependency, and then you can actually implement that interface that has those two methods. And that's the methods that you need to be able to control how your application is handling this kind of being frozen down and being unfrozen at some point again. Because that thing runs on Linux. It's only Linux supported on the Linux platform because, well, most of our containers are Linux-based, right? And everything in Linux is handles, file handlers, right? Handles. And those file handles will need to be closed down and recreated, no matter what it is. If it is just actual file handle, if it is a network connection, or if it is a database connection, which is kind of a network connection anyway as well, or all the other things that you might have. You need to handle that if your framework you're running on does not support it. There are frameworks that implemented a bit more of a support, things like Spring Boot that you've been talking about, and others. If you don't, you need to do that, and you also need to do that if you're doing something very special in your application as well. I'll explain and show how that works in a demo in a bit as well. What is important to think about is that you'll need to do that for every resource that you are running. So, one class you have database connection. You need to do that. Another class you have a files or whatever connection or some other stuff. You need to do that. And then you will need to keep on doing that. But the cool thing is that if you're running on a platform that does not support crack, or if you don't use this checkpoints and anything, the code can be there, but it will not be triggered or run at all. So you can run on any JVM really, but it will not be visible. It will never be run again. And so you'll not get any errors. You'll not get any things. But this stuff is supported on Zulu. So Azul has its own JVM that is called Zulu, and then you can actually do that on that JVM. I mean, it's free to use, to download and to put into your containers and stuff like that, the community version. And it just works. If you're running on anything else, if we have time, we may see it later. If you're running on some other JVM, that's fine. It's not just going to trigger, but it's still going to behave as nothing happened. Right. How do you do that? Well, you just add a few extra options to your Java command. So to actually create checkpoint, you just create crack checkpoint 2 and give it a path. Then you will need to run a command to actually stop the world, stop the JVM, dump the contents, and kill the container. And then when you restore it, you will just do restore from and then still give it a path. Typically what you do, if you do it inside containers, I'll show that in the demo, but for now you'll need to probably, the best ways would be to create a folder inside a container or somewhere where you want to state, but you map that folder to something outside a container, so you actually still have those files when container dies. And then you create a new container, you again map, or what do you call that? Linux. My brain is not braining. When you map folders.
Symlink or something.
Yeah, well, you mount. That's the word I was looking for. Yeah. You mount basically this thing through Docker, and it just works. Right. So there are several ways of doing that. The original one, I mean, the way it started first, it was based on something called Cryo. Cryo, that's a part of a Linux kernel. It's the way Linux does this hibernation. I kind of should stop using hibernate because people get confused by hibernate as a database thing. We're not talking about that. We're talking about going to sleep. Computers hibernate, yes. Mm-hmm. Not they. Yeah, that's fair. Cool. So this is based on Cryo. So that's a part of the Linux kernel. It's been a part of the Linux kernel for quite some time, and you can do that. There are some issues that I've been experiencing with using directly Cryo because it has some issues with PIDs, and it also requires your containers to run in privileged mode. So that some people don't like that. So if you don't like that, there is another thing. There's something called warp. And then you just, the way you activate it, you just say crack engine equals warp, and then it will just switch to this thing. So it's something that Azul created on their own stuff, or kind of wrapped around. And that thing solves a lot of issues. So I've had a lot of problems, for example, with PIDs, being conflicting PIDs, because whenever you start a new Docker container, it starts counting the PIDs from some number, and then you get some conflicts, and when it restarts, it expects to have the same PID. If that PID is taken, it gets very, very grumpy, and all these kind of things. That thing solves a lot of that.
Does it require operating system support, Warp?
No, Warp is part of JVM, so it's part of the Zulu thing. It's just it's a JVM thing. So as you can see, why is there no? I want animation. Come on, there you go. So this this thing that you provide, this is this thing you send to Java. So in front of that would be Java, and then you do -xxx.
Do you need a special JVM?
Zulu.
Zulu.
Zulu is the JVM, so that's the one made by Azul, built by Azul. It's open JDK based build, but it is it's their own, because this support is not part of OpenJDK project. It is part of a JDK project, but it's not part of all the JVMs, JVM builds or distributions. So for now, it's part of only Zulu. There are, we're going to mention, do we have a slide, or we removed that slide about Instant On?
I think we removed it.
We removed it. But there are other supports for that as well. So there are some other providers that also have similar or pretty much the same kind of thing. So for one of them would be OpenJ9 that has something called Instant On. It's a bit different, but it's... sorry, what?
What's the name?
OpenJ9.
OpenJ9. That's made by IBM. So it's their build of OpenJDK. Right. Okay, so Jakarta Ion Crack. So what is, how do we make this thing work together? Because, like I said, some of them, like Spring Boot, they have it built in, and sometimes they would create already a checkpoint when your application starts automatically for you, and then you can create more checkpoints, and you can shorten down the boot time or startup time even more. But here we don't have that support yet. We'll talk about that as well, but we need to fix
but we
somehow,
we have something similar that we can hook into and use. So,
Exactly.
so we have sort of this thing.
Yeah.
And one of the specifications in Jakarta is CDI. And that stands for context and dependency injection. And this is a very important specification in Jakarta. It's sort of the glue that glues everything together. So if you're a Spring developer, you would know about the Spring context and creating beans and that kind of stuff. Mm. That's what CDI does in Jakarta. So and the latest version of CDI is version 4.1. You can read more about it on this link. And what we're going to talk about a little bit, or actually one event, is they have these CDI application lifecycle events. So we can make the application aware of where in the lifecycle of the application is. It's built into CDI, so we just have to observe that.
Yes.
And the way we observe that is that we use the add observes annotation and just observe when the application scope context is initialized. Mm. And then we can use that.
And inside there, you can use, so what the thing is that Crack provides both programming APIs and also command line API, command line options. So you can instantiate, or you start the checkpoints and restores and all this kind of things. And this is where you can, for example, hook in and say, you know what? When my application starts, I want to create a checkpoint, or I want to do that, and then so you can just hook into this thing.
Yeah. So when it observes that the application scope class is initialized, then the application is initialized, and then you can do the before checkpoint thing.
Yeah.
Yeah. And the same way is that before it goes down, then you can do the cleanup thing, and that is to absorb the at destroyed. So this is a way we can kind of know where in the application lifecycle we are.
Yeah. And it's really handy because it also helped us to measure, because we wanted to measure, we'll talk about that in the demo a bit, but we wanted to measure actually to have a numbers on how long does it take for a container to start. And it's not that easy to measure because there's a lot of things that has to happen. First, you build an image, that doesn't matter, that's fine. It's already there, image is ready. But then you start putting your image, your whatever operating system is on that image, you put your application, and all those things are happening. And it's kind of hard to measure from the moment you send the command to start the image.
Yeah.
And that's what we were using, because in it, we could actually pick that number from the timestamp of starting the build of a container and do some simple math to actually show the proper startup time.
Yeah, so here we know when the application is initialized and we know when it's going down. And here we can grab some information or do some stuff, prepare for things. And then the crack API comes in, where if you remember the dependency, if you add the org crack, and then you can create for example, some startup listener that implements the resource interface. And in this interface, we know we can tell crack what's going to happen before a checkpoint is created, and then at the same time after a restore comes back. So here we can use the information that we gathered in the lifecycle events.
Is there a registry where the various listeners will be put in so that your init can iterate through the registry, or is it scanning through application scope annotation?
In this case, it would scan through application scope in the example we're doing, but CDI is very powerful, so you can do any ways of doing this. So there are different ways of doing this. This is kind of the easy way of just checking it out.
So just for the camera, the question was if there is a way of putting all those listeners together, or having like a repository of all the listeners, or not.
You probably can.
Yeah.
But one thing that also helps us in Jikari is that, you know, the notion of application servers. So these application servers manage a lot of things for us. So in the application, in a Spring Boot application, you would sort of manage things in the application, more or less. But in an application server, we have this. We just ask for things. So I ask for a JDB connection, or I ask for a connection to something else, or I ask for whatever resource. And it's given to me and provided by the container via some mechanisms they have. It can be different things, and depends on which technology. And that kind of helps us in this thing, because we can have external resources as well that the application server handles some of them. When a CDI lifecycle is that it's going down, we can kind of, okay, you also need to take care of these application-specific resources. So we can tell the container to, hey, this is something we want back again. And this is what we can do in these.
And the cool thing is that a lot of some of application servers are starting to implement that already. So one of the things that I mentioned a bit earlier that we'll talk about, might as well mention it now. For example, you know, if we go tiny little bit back to this, where did we have the, no, I'm too far forward. When we have dependency here. So when it's there. So, oh, come on. One more time. Oh, well, anyway, that dependency, that Maven thing that you had, this is the vanilla one. But for example, for Helidon that we've been using as one of the demos, they have implemented their own wrapper around it. So it actually says Helidon-crack, because if you just throw this one in, it would give you an issue where it will not create a checkpoint because it thinks that HTTP connection is still open, so HTTP socket is still open, and it will just fail. And then they made some kind of wrappers around it, so then you just import a different one. I'll show which one it is in a bit. Yes.
So I think we were
somewhere
there. All right. So we kind of set the stage a little bit. I mean, we haven't explained everything in detail. We've kind of touched on it. We wanted to spend some time in the demo.
Yeah. You want to see some demo? You want to see some code? Oh, sure. That's nice. That's the only correct answer. All right. So what I did.
So before you start, did you remember to delete the file?
Ooh,
I'm supposed to ask him that.
Yes, thank you. Because actually, I think I did.
Yeah, good.
Because it seems empty.
Good for you.
I think. Okay, so what I did, I have I needed a project for a demo, so I created this project called Random Strings that gives you, it reads from two, let's see, Java, where is Java? things on stage look very different than it is on your screen. So
it's because you have the light theme. And
Exactly.
you're used to the, and you know why developers prefer the dark theme.
Oh, it's a bad joke, yes.
It's a cracking
do you guys
joke.
know? It's a cracking joke. Because light attracts bugs. Yes. I know. I mean, we're really good at jokes. So we're in town hall week too. So, but so the idea is you have two enums of one is with nouns and one is with adjectives. It will randomly go into that enum, pick one, and pick the other one. Just give you a pair of noun and an adjective, or actually adjective and a noun. But yeah, you get the point, right? So then it will just it has a controller that does all that, and the endpoint is R&D. So first, the application endpoint has the /API. That's the kind of top level URL so localhost /API or whatever domain is /API. And inside a controller, it would have. Go away! I don't need to show this. Okay, this is close annotations. Yes, that's exactly what I wanted. There you go. Then you have a /R&D, that the endpoint that will actually get this pair of two words back to you. We've used a bunch of things to actually tell what it is, and we have some metrics and stuff, but that's not important things. The most important thing that it actually runs, and then we can actually test it, and we can, for example, do it very simple as, let's see. So actually, you know what? I'm going to show. So it's open repository. It's a public repository that's called, and if you go to README file, it will contain all the fun things. I'll go into preview mode here. So, for example, you can compile it with different runtimes. So Helidon, Quarkus, OpenLiberty, you just pick the one you want, and then you can just go, for example, with this one. You copy this. So it has the way it works. It has actually.
Should we explain what Helidon is first?
Oh yeah.
So yeah, so Helidon is a open source project. It's a product from Oracle. It is a core profile compatible. If you remember the Jakarta E profiles, so it's core profile compatible, and it is a fairly fast, small runtime for creating microservices and like RESTful applications like this one.
And so what I do here is that I on purpose have different POM files. So that's the only thing that's changing. That's only POM file. We have still the same code. And that's why we have like a separate ones for all these things. And if we go, yeah, your Firefox has been updated. Thank you very much. That's exactly what I wanted. Local host API R&D. So that is ready. We'll press enter in a second. So what do we need to do now? We just run it, java-jar, and then we can see that it should return us some stuff. Endpoint? No. Oh yeah, of course. I need to learn to type. See? And then we kind of refresh, and it keeps giving you new random selections of words. So this is just running locally with java-jar. What I've done also, we have a bunch of scripts just to build containers and stuff like that. So we can start with maybe this one. You can ignore this part. It's just to simplify some command line stuff. The fun thing that really happens is here. So you're building one container that I give a tag called regular. I needed something to call it, so it's called regular, vanilla, whatever. So this one does not contain any crack stuff, and it runs on a Docker file based on the runtime. And runtimes that I am allowed to provide is Quarkus or Helidon.
So the regular container is something you can bring home to your parents. It's not on anything.
Yes, yeah. You can actually tell. Yes, you don't have to have a talk with your parents that you're using crack.
Yeah.
Yes. The improv jokes are really amazing. But so what I did was also I have a bunch of different sets of Docker files that you can actually do different things. So you can do JVM version, native versions, crack version, and so on. And the files will be more or less the same. They will be multi-stage builds where you do first a Maven build, the Maven container with Maven build, and then you copy those artifacts into the next container, and then you do basically the same thing as we saw. For example, java-jar, random strings jar. This is Helidon JVM version, right? So if we go back to the startup script, we create a Docker image with this thing, and then we do the start command timestamp milliseconds. Very nice. Naming things is hard. So this is a very nice environment variable where we put a current epoch time in milliseconds and just store it there because we'll use it later. And then we actually do Docker run. So we build a container here, we run the container here, and we provide the same timestamp milliseconds into a container. So now container knows when it was told to start. And then we're running this regular thing, right? So if we do this again here, I'll kill this thing, and then we'll do, what's it called again? Startup node crash. There. See, I can provide if I want to do runtime Helidon or if I want to do runtime Quarkus. But Helidon, it is. So see, now it's building a Docker container. It might take some time, but we don't care about that part. That's not what we're measuring. We're actually measuring the other thing. And now it's already built. And it actually says that startup elapsed 2.42 seconds. So it was 2.42 seconds since we started that thing. It was already up and running. And if we go back to this URL, it will still give us new things. And it's a different, same endpoint, same URL, but it's different. It's this.
This output, was that from the, did you do that from the Java code to print
Yes.
this string?
So we did that. We did that through, now it's the fun part starts. So we created this listener called startup listener. The important things are not important, if you can say that. But you see this bunch of stars here and startup initializer initialized. That is this one. Startup listener initialized. And this is where we pick up this start command timestamp milliseconds. I should find a better name for this. And then you actually do elapsed time. You calculate elapsed time from current time minus started time that I got from that environment variable. Go away documentation. And then you just print it. And this is really cool because this is the way, we're using it to measure startup time, but it's actually a very good way to also do things at a startup. Next is, you can do the same thing as destroy. For destroy, it's not, we didn't do anything except for print out. And I can actually show you that it works when if I kill it. Right, Control C. See, it actually did run that. It did run the destroyed and printed that out.
Yeah. So these are the CDI lifecycle events that we talked about.
And now we've also baked two things into this. So we now implement a resource, and resource is a crack thing. It's from the crack library. Here we can actually do more stuff. And as you can see, this stuff is not being triggered because if we look again at the Helidon JVM Docker file that we've been using, you can see that we've been using Red Hat's OpenJDK build here. It's not Zulu. And it still runs, no errors, no nothing. Now, when we'll be using crack, we'll be using this Docker file. And here you can see it's at the beginning of the same. We're building Maven stuff and things. And here we're starting, this is where the fun part begins. You have Azul Zulu OpenJDK 21 with crack latest. Putting latest into your Docker files, that probably may not be a good idea, may or may not, because you don't have a control over versions and stuff, but for the demos, it works. For production, maybe not a good idea, just saying that. And also what we do change here, instead of doing java-jar, we actually have a little bit more fancy entry point shell script that will be different. So we have one for Helidon and one for Quarkus because they're a tiny little bit different. Shell scripts, they do few things. So first, what you'll see that we're creating a folder called opt crack files, and we map that folder. Later on, you'll see that we'll map that folder to, or mount that folder to random string crack files. So this thing will be here. Now, this makes sense so far. Yeah, good. And then we do, okay, so we go up. And then I can actually, instead of this, I can do checkpoint, runtime, Helidon. Actually, Helidon is default, so I don't have to provide it, but I just do it because, so you can actually see which one it is.
So what we're doing now is starting up the application.
Yes, it did start already. You see, it was
Yeah.
startup successful. And now it's creating checkpoint. It will take a bit longer time than it actually should, simply because right now we're in this file, entry point sh, and it has a slip. And no, actually, wait, it's not. I'm lying to you. We're here. So it is in creating checkpoint. Please wait, and it sleeps for 20 seconds to make sure that the file is being created. And now we can actually see that this one has core image. And here we're using warp. So we're not using a cryo, but we're using warp as an engine. And as I told you, the way you do that, let me hide this for a second. The way you do that is it's, yeah, I know what it is, but so here you're doing actually crack warp files in here. So this is the entry point inside the Docker container that's being copied, and it does some things. So you can see it says hello from the container and no checkpoints found if that folder is empty, and if it's not, then it will actually try to restore from there. If it's empty, it will try to create it. So then it actually starts up the application, waits for 10 seconds, and does this command that stops everything and dumps it to a file. And that's how things are created here. That's how this one, that image file appears.
What's the purpose of sleep time?
It's just to make sure that application is able to start properly and starts and runs for a little bit. That's all. You're
trying to overcome the warm-up time?
Kind of that, but also boot time for an application, because it might take some time for.
Oh, you're running it in the background.
Yeah.
Ampersand.
Yes, exactly.
So you expect the startup to be finished within 10 seconds.
Yeah, pretty.
And then you're doing a checkpoint.
So yes, we're waiting for application to start for startup to finish in 10 seconds, and then we're running checkpoint. Yeah. You can do it in a different way. This is a kind of the basic primitive way of doing it, but you can do it a bit more fancy way, in a fancier way as well.
Yeah, and if you have an application that takes longer to start up, you will just increase that number.
Yeah, you can do that. Yeah. And then, but what it does actually, after this, it actually sleeps for infinity just to wait for those files to be copied out as well, and in the script. So my script actually kills that container after a while when it's done doing things to it. Sounds bad, but yeah.
So before your resource interface,
Yep.
before checkpoint, was that the method name? Before checkpoint?
Yes, that's correct.
Before checkpoint, you closed all the socket descriptors, all of that.
For example, yes.
So then it's already dead.
It is.
There's no point in letting in it. So why did the framework not kill it automatically rather than expecting you to kill it manually? Simply because you don't. So if container dies immediately, files are gone. You want to be able to give it some time and just let it be there, so you're done with, because the way we're running it, it's something with. I mean, it's the way we implemented it in a for simple. You see, it says RM, so it will disappear when container is not running anymore. It will be gone and deleted and cleaned up. And this is kind of what you really want, because you don't really need your containers to be running there, because then they will end up like polluting all this thing. See, I took a screenshot. Okay, we'll see that. Let me run this and you'll see it.
So checkpoint, runtime Helidon, I'll run it again. You see the container is there. It's actually booting and doing its thing. And in 20 seconds, it will be gone. So
while you're showing that,
yeah,
10-minute checkpoint.
Okay. We have 10 minutes left? Okay, good. Perfect. See, it's disappeared now because it's done all its things, and now we can clean up that as well. You'll still see it as an image, but, and what we do is that we create a builder image and we create a checkpoint image afterwards. So now, when we'll be starting the crack version of it, now you will be starting the checkpointed tag. So if we go back to the scripts, so checkpoint here, it will clean up. It will kill the container ID. It will find the container ID by its name. It will kill it, but it also needs to create this new image. That's why we're keeping it sleeping for infinity, because we need to modify. You see, you're doing here Docker commit. You're actually changing an entry point, and you're changing. You're creating a new checkpoint tag, and you're pushing this new tag into it with those files and everything. So that's why we need for it to sleep before we can actually kill it. And next thing, we just kill container ID, and now it's done. So again, this can be made in a prettier way, but this was made simple without all the magic, exactly to be able to for demo purposes, really. So when we were doing restore, you see it didn't get all that boot information, all that. It just started from where it was. And now we already have this restore thing with elapsed time. We didn't have that. You didn't see that before now. And that is because what is happening is that now we're in the same listener file, startup listener, but it isn't here. And that is happening after restore. So now we're actually invoking this after restore method. And if you were fast enough, you could have actually seen the before checkpoint, this being printed inside the container. I can do that again. I'll just delete the file, so it will create a new one. And if we go back to checkpoint, I run it. I run really quickly back to my containers here. Soon you'll see this. Startup listener, yeah, before checkpoints. You see, it's there. And now the container will soon disappear. But this is triggered inside the container. So you're seeing the output inside the container, and the other one is showing us the output from when we're doing restore. There. And we can also measure the time of the startup of the crack version of a container with crack. We've done the same thing with that's the kind of cool thing that we can actually do also Quarkus, and it will do the same thing. Actually,
so Quarkus is the Red Hat. It sort of implements the core profile as well. Mm-hmm. It's kind of comparable to Helidon, but it's from the Red Hat.
And the funny thing is that, I don't know, you see there's a lot of complaining going on. That's because I tried to use the image. That's why Ivar was asking if I deleted the image. I did not delete it, and I tried to restore Quarkus things, Helidon things into Quarkus, and obviously Quarkus was a bit disappointed. But if we delete it again and run it, it will take a few seconds. Then you can actually run the same thing on Quarkus, and it will be still there. And while it's building, we can see that. Why the heck is it actually returning anything? Oh yeah, because the container the checkpoint thing is running. Yeah, okay. That's actually funny. Mm-hmm. So now it's killed, and now it should not return anything. See, it says unable to connect. And now we can do restore Quarkus. And it started in less than like 800 milliseconds, refresh, back. Now it's Quarkus serving the same thing. The main idea, the main takeaways from here, you need actually to have a look at these things, and you have to be able to use the init methods and destroy methods, and also before checkpoint and after restore methods. And like I said, you will need to implement it for the same thing for those the checkpoint things. You'll need to implement it per resource file if you have them. So, for example, I implemented it here, but I also implemented it in a string supplier. So I'm doing the same thing, implements resource, and all of a sudden the supplier has those two overrides here as well. And by the way, if you want to make sure that your classes are eagerly initialized, not lazily initialized, this is a trick. You create an empty method to tell JVM to force eager initialization of a class. That's a fun thing that I learned by talking to people and digging into documentation and stuff like that. And it's one of 4 ways of telling JVM to actually eagerly initialize your stuff.
That was cool.
That was
cool. If you go back to the slides.
Let's go back to the slides.
So I had Rustam do this 10 times to get some average numbers. So while he was running it, I was creating some slides there. And you can see Quarkus is slightly faster than Helidon on the no crack. So on his computer, this is we'll get to what the specs are. If we run it with crack, you can see there is much more gain with Helidon than with Quarkus. So Quarkus is just slightly, it's not even worth the effort to use crack for Quarkus. But for Helidon, you see, you earn him a second on this Intel, whatever, corner.
But again, this is a very simple implementation.
Yes,
yeah. If you have your more complicated thing, things will be different.
But it is a good idea to measure that you actually get effect from it. Because if you don't get effect from it, then you probably are spending a lot of time doing something that probably wasn't necessary. And so this is a good example that it depends on the runtime you're using. It's exactly the same code, but since they implement Jakarta specifications, you can use the same code on different runtime. So you can actually take your application and just move it between runtimes and check it out.
This comparison was probably, the checkpoint was taken immediately after startup.
Yes, it was the code we saw here.
So include the effect of JIT going through C2.
No, not yet. No. Yes, so that's...
If you had, that would have been a considerable difference.
Probably. Yeah. It could have been. But we wanted just to do it as simple as possible and just do it because one of the ways would be also to do like a curl or something to actually call the command a few times and just warm it up a little bit, and that might have been different results. And also that just to mention, these things that you see here, it's actually on a slightly. I mean, it used to be a powerful machine, but this is Intel machine. This is Intel i9. So this is a machine that is. It might also look different.
So
on the M.
We have only a minute left. So let's sum it up, so we don't go into the next speaker. So the Jakarta platform is there. It's coming soon in 2025. Actually, not 2024, but it's introducing Java 21 and some other stuff. Jakarta and Crack works very nice together. It has these lifecycle events. You can figure this out. You can hook into it. But it would be a very cool idea to think of a Jakarta Crack specification, so we can actually create a proper support for it, and that org Crack API is a good candidate for being that API. So that is an idea. There is also something called Laden. It kind of solves the same thing, but not really. It does more things on the compile time thing. But Project Laden is also something that will increase the startup applications that are worthwhile looking at. But it's not the same thing as Crack, and it doesn't really solve the same thing.
No, it's different level and all these things. But yeah, it's something to look at. If you want to look at something, this is it. And speaking of more things to look at, you can look at the pictures of us, obviously, in the corner there. That's how you find us on the social media. But probably the things that you might be more interested in is all the Jakarta and getting started.
And you have the demo code in Rustam's GitHub. So go there and check out the code with all the nice README files, and it should be easy to get it up and running on your application. If you want to just try plain vanilla Jakarta, go to start Jakarta.e and generator project.
If you want to make it run, figure out all the crack things, just scroll down on the main README file down to the crack section, and it will tell you all the scripts and where they are and all that.
Yeah. So with that, we thank you very much for listening. And please don't be shy and visit us at the booth and ask more questions. And if you want to talk about crack or other thing, or crack a joke, then come to us.
Amazing. Thank you all for joining us. Have a nice day.
Great. I got a question.
Yes.
When we talk about crack engines, right?
Right.
The original one was Creo. Was the pronunciation Creo?
Cryo, yes. That's Linux thing.
Yeah.
Yes.
So that was just running on Linux.
Only
Linux.
Yes.
What about Warm? Can I use it right on Mac and Windows?
Warp, I think it's also Windows. Sorry, Linux-based thing. Yes, because it's something to do with the way it's operating system thing. Because you need a way to tell the operating system and to close all the handles and all this kind of thing. So it's a limitation. So I'm pretty sure Mac OS has its own thing, but I'm not sure if it's open for everyone, so you can actually, hibernate. Because it's not really about it's about hibernating a container. It's not the Linux as there's no point on using it directly on your machine. You really want to use it with a container, because then it shuts down the whole operating system.
All right.
Question as well?
Of course.
That was impressive. But what I could not quite understand is, where is Jakarta in the picture? Is there I'm not talking about the reference implementation.
Yeah.
Is there a language, as in E language, new annotations or language enhancements to listeners and as such? Is there any enhancement in the Jakarta, the upcoming specification for crack?
So that was what I was talking. Jakarta crack would have been a good specification for us. We could create an annotation like at before checkpoint, for example, and use the org crack APIs to hook into that. So it's something, it's not supported now. It's not even proposed as a specification. I'll just throw it up there as a good idea. If you think it is a good idea, I would like to talk more to you and we can try to pursue it.
So right now, forgive me, 11 doesn't have anything as it stands.
No, you would have to do that, listen to the application scope or whatever, the CDI application cycle events, or implement the resource.
So you'll need to do it
correct
yourself. But if it will be implemented, so the way it has, for example, for Spring Boot, Spring Boot does a bunch of things, but you can still use. So what it does for you automatically, it creates a checkpoint right after you start your application, exactly what we did here, and then it will. But what you can do is you can shorten that boot time even further to create another checkpoint after your application is started and like after everything is. So what Spring Boot is doing, it's cutting its own boot time, not your application really. And then what you can do is you can add also your application boot on top of it and create another checkpoint and use to load that checkpoint next time you start your containers. And then you'll see a much shorter startup time. Well, shorter, maybe not much, but shorter startup time, depending on your application.
Another aspect to it is that even though it's an OpenJDK project, it's not part of the OpenJDK yet.
Yeah.
So until it's part of the OpenJDK, so it can be supported by multiple vendors, it doesn't really make sense for Jakarta to standardize it, because then we would tie into one vendor.
But the reason we did what we did was to actually show that you can do this for now manually, but you'll get the same results, and then you can build on top of that. Yeah, I mean, scripts is just to show you how it's done. You normally in production you'll probably use something else. You'll use some other ways of handling Docker and starting and everything. But for me, scripts was just so I can document which commands are being run after each other without really creating huge README files. And
Yeah,
stuff.
the important thing is that startup listener class. That's where things are happening. So.
And my scripts still have -- privileged because I was running until yesterday, I was running on Cryo, and then I switched to Warp, so I can actually now, I will probably remove privileged from the Docker commands, but for now it actually still contains privileged. Because I was running on Cryo until very, very recently, and just I had some issues and problems, and then also generates many more files in this crack folder. But then when I switched to Warp, it's just one file. It doesn't have this PID conflicts and all this. So then I just did that.
Yeah, I saw privilege.
Yeah. That's because that's from Cryo.
There's a way to do Linux capabilities.
Yes, you can see. Yes, I know what you mean. That's also in the if you look at the restore file, it's there. It's something cap, set cap or something. Yes, it's also there. Yes, of course.
I somehow missed the question of the open ports. So it's done automatically for me. I don't need to care from inside the application. I don't need to care about it.
What do you mean?
What I mean is the open port for the rest, for example. So if do I need to do anything about it, or the crack takes care of the open ports and then?
Oh, you mean the file handlers and stuff like that? Mm-hmm. If you have it, you will need to recreate them. So typically database connections and the file handlers, if you have a connection to the files all the time, if you're like, for example, using your application to look at files and see if they're changed or something that you constantly have an open handler to, you will need to do that. You will need to close them down before a checkpoint and restart them after.
Yeah, and it's the same thing if you're using connectors, for example, to something, then you can use the resource into the connectors, the SPI there. You can get hold of them.
And the REST endpoints, web servers.
Yeah.
You will need to do that for now if you're using Jakarta, but things like Micronaut and Spring Boot, they do support that already because they have implemented their own support. But they still, it's the thing, right? So they say it's supported, and it is supported, so you don't have to do all these kind of things, most of the things manually, but it will still create checkpoints only at some point. If you want to do it more fine-grained, you still have to do that, right? But then it will be a little bit less hassle, and then you can use it with Jakarta now, and then you will have to do a little bit more work, but then at the same time, it's more centralized, so maybe it's not going to be that much more work, really. But yeah, our thought was to actually see if we can make it work and we can make it behave the way we want it to be, also with Jakarta, and it worked, and that's kind of. Thank you.